Hey, what's up, Math 1? This is Mr. Bainey. The lesson we're going to look at today is 9.3, histograms and box plots. The essential question is, how can you interpret and compare data sets using data displays? Before I begin this lesson, I want to thank you for watching my video. Hopefully it's helping you out. And I can have a little reward for you, maybe a PBIS point or something else, if you come in and see me the next day that you have class and tell me a math joke. Hopefully on a Monday or something like that, where it's a rough day for all of us. So this lesson is sort of a continuation of 9.2, which is we're dealing with one variable data, right? We learned how to do dot plots, display it that way. We've dealt with data distribution shapes, if it's symmetric or if it's skewed. We calculate things like mean, median, mean and median, and also range, IQR, and standard deviation. So we're going to continue to do some of those things, but we're looking at not just dot plots, but also histograms and box plots are two other displays. So what you see right here on the first page is a histogram. So a histogram is like a bar graph, and it's going to display the frequency of intervals. So we're still dealing with numbers here. And so you can start to read the histogram on the right side. We're going to answer some questions about it. The first question is, look at the histogram of scores on a math test. Which axis indicates the frequency? And it is the y-axis. Remember that frequency is the amount of times that score happens. The horizontal axis indicates the test scores. And it is organized, I'm on part C now, in groups of 10. So what you want to look at, if you see the graph over on the right side, it does go from 60 to 69. So a very common mistake is that students will take 60 and 69 and subtract those, and they'll think that the interval is 9. In fact, it's not. So we're going to be mainly looking at how far is it apart from the first number here in 60 to the beginning of the next interval, 70. And so that is 10 apart. So you can think 70 minus 60, or if you were to list all the numbers starting with 60, 61, 62, 63, and so on until 68 and then 69. This is actually 10 numbers. 10 numbers, and that's why our interval size is 10, or our interval group is 10. So scores of 60 to 69, there are 3 scores. So the frequency, I'm looking at this right here, it's a 3. From 70 to 79, there's 9. From 80 to 89, there's 12, and 90 to 99, there are 7. You can add up all of these frequencies together to get the total number of frequencies, or the total number of scores. So it looks like it'd be 10 here plus 21, so 31. So this looks like it's about a full class. 31 scores are shown or displayed on this histogram. Okay, if you take a look at part B, we're going to create a histogram. Here's scores from a golf tournament. So you see them listed here on that second line. We're going to create a frequency table. The data values range from blank to blank. So in order to start our frequency table, we got to know our lowest score. And then in order to figure out the interval groups, the size of them, we got to get our highest score. So that way we're not creating groups that are too big or too small. So it looks like my smallest number is 68. And the biggest is 78, it looks like. I'm just doing this by observation. And then we want to think about how far apart are those two numbers, or how many numbers are included within that. There's actually 11 numbers. I didn't just subtract because I have to also, I could subtract 78 minus 68 is 10, but I got to include 68 as well. So if you list 68, 69, 70, 71, 72, 73, 74, all the way to 78, there's 11 total numbers there. So what I would like to do or think about is um, what's the size of the intervals? In this problem, it just tells me that we're going to use the interval width of 3. But if I didn't know that, then you want to think about on this histogram, I want to do maybe like 4 or 5 bars. And how would I do that? So I can take this and I can divide it by 4, and I would get about 3. Or at least if I went by let's say 2s, I would have maybe like 6 or so bars. If I went by 5s, it would give me 3, so that'd be a little bit too small. If I did 4, about the same, about 3 bars, which is still too little. So 3 is kind of the sweet spot for this range of values. So if it's an interval width of 3, that means I'm going to go from 68 to 70 because it includes 68, 69, and 70. Then I have 71 to 73, 74 to 76, and 77 to 79. Notice my highest interval, or the last interval goes up to 79, but my highest number is 78. That's okay. I don't need the last number in my biggest interval, sorry, my last interval, to match the highest number. Doesn't need to. Okay, what's important is that all the numbers in this data set, it belongs to one of these intervals. That's the important thing. So I'm going to fill in this frequency table, and I can start creating my frequency table. My highest frequency is a 7, so on my y-axis, I can go by ones here and be able to fit it in just fine. Up to 7. I'm going to have my intervals here along the x-axis. My first bar is going to be in here 68 to 70. Then I'm going to have 71 to 73, 74 to 76, and 77 to 79. So my first bar is going to go up to 3, so it's going to be like this. Try to draw it as neat as I can. 71 to 73 is up to 4. So these bars in this histogram are going to be like side by side. They're going to be touching each other on the edges, and so that's okay, unless it's a 0 frequency for that particular interval. They're going to be side by side. Okay, there's a third interval, and the last one is just a 2. It doesn't also need to go all the way to the edge of this. If it ends earlier, that's totally fine. So there it is. That's the histogram for this data set. You can certainly figure out that the sum of the frequencies is going to give us 16. That means there are 16 golf scores, or 16 data points. And then that's all that's expected here. So I'm going to have you practice this at the bottom of the page. Go ahead and pause it right now so that you can give it a try. I'm going to have the answer pop up here in a few seconds. First, I found my least value, my smallest data point, and my biggest data point. I found out that the range was 16. And so I thought maybe an interval width of about 4 or 5. I decided 5, and when I made my intervals of 5, width of 5, I found that there were 4 of them, because for me to get up to 79, I'd have to make this one, which includes numbers that, aren't part of the data set. If I did 4, an interval width of 4, I would have 5 bars in my histogram. So 4 or 5 would work in this case. So here I sort of did this in preparation for the histogram. I did my intervals, and then I wrote the frequency. So I went through up here and I crossed out all the numbers. You could certainly add up all the frequencies together. We would get 15, so there should be 15 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And on the right side is my histogram. You can see there's my 4 bars, my 4 intervals. I went by ones because I only need to go up to 7. And there you have it. Okay, so this first part is just creating the histogram from a set of data. You can begin to think about how this might be helpful for us. If all we have is the histogram, like what good does this do for us? How could we use it? Especially based on what we've learned so far. Okay, next we're going to take a look at what the process is of calculating some of our statistics. And the main one that we're going to work on is mean, or the average. And so on page 404 at the bottom, I'm going to look at part B. I'm not actually going to do this problem. I might fill in the first couple of rows of blanks here, just to kind of get you started, and you can certainly finish it up if you'd like. But the gist here is that I have only one score, or one result, one data point that's in this interval of 160 to 179. Do I know what specifically that data value is? I don't, because it's within these. So this is the hard part about histograms, is that we don't know. We know what it could be. I mean, it could be 165, could be 172, could be 179, could be anything, right? So we're gonna assume that this data value is halfway, exactly halfway, in between 160 and 179. So the way they found that halfway point between that is they found the average. So if you go all the way over here, they did 160 plus 179 divided by 2. So that will help find the average, and that actually gives, if I want to write it on the graph, it's going to give us 169.5. So I'm going to pretend that one data value, because there's only one of them, that's the frequency, is 169.5. So we're doing 169.5 times 1. There's only one of them. From there, the second interval, there's 2 of them. Okay, so this right here, I'm going to find the halfway point between 180 and 199, and that's 189.5. I'm going to now assume that both of these data values, there's 2 of them, are both 189.5. So remember that when we find the mean, we add up all of the data values. So that's essentially what we're doing. We're assuming that all of the data values are right smack in the middle of each interval, and then we're kind of like combining them all together. So we're saying that we have 2 of these 189.5. So I could do 189.5 plus 189.5, or we can just multiply it by 2. Okay, and that's probably a quicker way for us. Now in this one right here, this third histogram bar, 200 to 219, the halfway point inside of that interval is 209.5. If I find that average, and I have 4 of those. So I could do 209.5 plus 209.5 plus 209.5 plus 209.5. Or I could just take that 209.5 times 4. If I do the same thing with the 4th interval and with the 5th interval that you see here on the left side, all of these 5 numbers, I'm going to add them together. And so you'll actually see them right down here, 169.5 plus 379 plus 838 plus, and so on. So this is the sum of all of the data values, assuming that each of them were the average of the interval. And then I'm going to divide it by how many total data values there are. This is the frequencies. So there's 1 here, 2 here, 4 here, 9 here, and 1 here. So they've added those frequencies together, and that's what they're dividing by, because there's 17 total data values. Once they take the sum divided by the amount of data values, you get your mean. Okay, so I want you to give your turn on the next page a try, and I will pause it, and then in a few seconds the solution will pop up. So the first thing I did was find the average, or the center of each interval. So from 4 to 6, the middle was 5. From 7 to 9, the middle was 8, and so on. So you see all of those here on the left side. Since I'm going to assume that all of this first interval are all data values of 5, and there's 5 of them. That's the frequency. So I did 5 times 5. The second interval has a center of 8. So I took, there's 4 of them, so 8 times 4. Did the same thing with the third and fourth interval. So I'm doing that and adding them together to get the total sum of all the data values. And I get 129. The frequencies, there's 5 of the first one, 4 of the second, 4 of the third, and 2 of this last one. So 5 plus 4 plus 4 plus 2 means it's going to be 15 on the bottom. I divide by 15 to get my estimated mean. Remember that this is just estimated because we're assuming that the data values in each interval are equal to that middle number, okay, or that average. So from here, we're going to look at the second type of data display, and that's box plots. So let's go ahead and make a dot plot here on the bottom of page 406. So we have to put these in order. So I'm going to put in order for number 8 and number 9. You're going to see it pop up in a few seconds. In order to make a box plot, we need to take this ordered set of numbers. We find the lowest value, the highest value, quartile 1, quartile 2, quartile 3. Remember that quartile 2 is the same thing as saying median. So here I need half of my data. There we go. Those 5 points, and I got those 5 points right there. So that means our median is in the center of 25 and 25. So I know that my median, or my Q2 is 25. My Q3 is right there, 26. My Q1 is 16. My lowest value is 15. My greatest value is 28. So those are the 5 data points that we need in order to create our box plot. So I'm going to make this box plot above the number line. That's how you're typically going to see it. Sometimes you'll see it on the number line, and that's okay. So no big deal as long as you have the numbers labeled. I have all the numbers labeled up here, so I don't need to label them again down here. I just try to make that as accurate as possible. So I got 15, and then I got 16. Looks like this goes by ones. So 16 is there. Ooh, then I got to go all the way to 25, and then 26, and then 28. So to make our box plot, we put a box around our IQR. And if you forgot what IQR is, it's the from quartile 1 to quartile 3. So the box represents, the inside of the box represents, or the size of it is the IQR. And then outside of the IQR are our whiskers. So from Q1 to the lowest value, from Q3 to the biggest value. And there you have it. So I am going to put up the solution for number 9. It's going to show up in a few minutes or a few seconds if you'd like to pause it now. And for number 9, I didn't quite finish making the boxes yet, but I wanted to point out that we have Q1 and Q2 end up being the same value, and that is okay. Sometimes you'll be missing parts of the box, or I mean, they can't really exist, or the whiskers as well. Sometimes the lowest value in one of the quartiles or the greatest value in one of the quartiles will also be the same value. So if you compare this to number 8, where we had the line going through the Q2 or our median, we're not going to have that in this case because our Q1 and Q2 are the same thing. So over here, we don't have the extra part of that box there. So here is our whiskers, and we're done with that box plot. Okay, and on to page 408, where we're going to look at the your turn, number 10. We're going to construct box plots, one for each data set. And actually, I'm going to go ahead and skip to number 11. This one we did in class, but we did not happen to do number 11. So that was something that's going to be a little bit different. You can try number 10 as well if you weren't in class to see that. And number 11 up here at the top, these are the ages of the 10 richest people in the world for both the years 2012 and then also for 2013. So we have 2 different data sets. What we're going to do is create box plots for each of these 2 data sets. I'm going to put one box plot. I'm going to erase this in a sec, but one box plot is going to go kind of like in this area right here, and then I'm going to put the other box plot just right above it like that. So try to line it up as best I can. So I'm going to have the answer pop up in a few seconds. When I'm done talking here, I'm going to explain that. I'm going to first put this in order. Remember, got to do that. Got to find the lowest value, Q1, Q2, Q3, and the greatest value, and then I can go forward with making that box plot. So pause it now before they see the solution. And here are the box plots. As you can see here, I took the data from 2012. I got my least value, quartile 1, quartile 2, quartile 3, and the greatest value. Did the same thing for 2013. And here are my box plots. So we can use this to try to figure out what are some of the comparisons we can make between each of the years, right? So these are the ages of the 10 richest people in the world. So we can say that for the 2012 data here is on the bottom, it has a bigger range. You can see that the box and whisker plot is longer. Like it starts at a lower value and it ends at a higher value. Has a bigger range. Also looks like the box is slightly bigger. So this is our IQR. IQR is also slightly bigger. The average age in 2013, or we can say the measure of censor here, remember that this is our median, is higher than in the following year. So it looks like on average, or if we're looking at the center, a lot of the 10 richest people in the world, several of them are, they're younger in age compared to the previous year. Okay, so I didn't write down those, but those are some of the things that you can mention when you're comparing these data sets. That's going to be it for this lesson. Thank you so much for watching. Have a great day.